So students, let us look at the total surface area of a cuboid. So for that, let us look at a cuboid. This is a cuboid, and you see that all the faces are rectangles. Even this is a rectangle, even though it looks like a square. And even if it is a square is a rectangle, so it doesn't matter. So all the sides, all the faces are rectangles. You see that? Now, so let us anyways mark few things so that we'll be able to find the total area. And this total surface area means the area of all these things, and the total area covered by this. Not the inside, not the capacity, not the space inside. That is volume. We are leaving the volume, we will study later. We are just looking the outer, the area here, area in all the sides. That is what we are trying to see. So first of all, let us mark the length. So if you start marking the length, we'll see that we'll take this side as a length. So if we take this side as a length, I'll call it L. So if this is L, this should be L. So we see that this is equal. These two sides are equal. We can see that. So then this side also should be L. Now if this side is L, I write the L here also so that I can understand. This side should also be L because it is a rectangle. It's opposite. Opposites are equal. And even if you didn't know that, by just looking you can see that these two sides are equal. So I'll call it L. I'll write the L here also for my better understanding. Now this side is L, this side is also L, opposite side. Call that L. And here I'll write L again because this side is L. Again opposite side will be L. So we see that all these sides are L, and this is where we started. So we came to the starting point. If this is L, I will call this side I will call it B or breadth. I will consider that to be the breadth. So it will be, this side will be the breadth. Now if this is breadth, this will be breadth, opposite side. Now this side is breadth, so here I will call it breadth again. And because this side is breadth, this side also has to be breadth. Now if this side is breadth, this is, I write it here again. If this side is breadth, this also has to be the breadth, so B, opposite side. Now again I write it B here so I can see that. If this is B, this also has to be B, opposite side, so it is a B. We come back to the starting point. Now we have this side. So you see we have this side. Now what is that side? That is our question. So we'll call that side anyways L. Sorry, H. Height. We'll call that the height. So this side is our height. Now if this side is height, I'll write it here again, H. Okay, so I can see that carefully. Now if this is H, this side has to be H. I'll write the H here again. Then this side has to be H. And here also write the H. And this side also has to be H. And then, okay, write the H again here. And then we come back to the starting point. So we got the length. We got because we said 3 dimensional, and we saw the 3 dimensions. Dimensions are length, breadth, height. Now you might think, sir, what are dimensions? Dimensions are basically directions that are perpendicular to each other that can be measured. Okay, for example, this is the direction B. H is a direction perpendicular. This is perpendicular, and there is another direction perpendicular to these two. B is perpendicular to L and perpendicular to H also. See, perpendicular, perpendicular, perpendicular. So these three sides. That is why it is called three dimensional. Because you can go in three directions which are perpendicular. You can go in this direction, you can go in this direction, and you can go down. All three directions are perpendicular to each other. So dimensions are basically directions which are perpendicular to each other. We can consider like that. It is not an official definition, it is just a definition that I am giving you for your understanding. And why are these dimensions taken? Because we need to measure things. We need to measure. Okay, anyways. Now, so hey, we didn't reach our aim. Our aim was to find the total surface area. So let us go on to that. I will keep two papers here, and then let us take a look at our cuboid. There are many faces. There are many surfaces here, here, here. We'll consider this as a first. So I'll call this number 1, L into B. So this area of this rectangle is L into B. Anyways, we just keep this rectangle here. Okay, and so this rectangle is our face 1. So this rectangle is our face 1. So the area of that, and this is the rectangle that we see. We have a length into breadth. That is our face 1. So I'll call this also face 1. Then if you look carefully, this face 1 is the same here also. That is the opposite, directly opposite face. Because here also it is L into B. Do you see that? So this side I'll call it face 2. So here again I'll call it face 1 and 2. So 1 and 2 both have the dimensions L, area L into B. Okay, then what all do we have? We have this face. What is this? L, and we'll keep it like this. L, and we have H. L and H. Okay, so we'll keep the L and H over our papers. And then what do we say? I'll call this face 3, and we see that this is our rectangle. So this is our face 3, and we see that the area of this rectangle is L into H. Now students, if you look carefully, you will see that the side directly opposite to this is this side, which is also having the dimensions L and H. That is, the area is L into H. Okay, if you want to see it in a better way, it is L into H. Do you see that? So what I will do is, so we see that that is also the same side. So I'll call that 4. It having the same area. So here I will write it 3 and 4. Why? Because both surfaces are having the area L into H. Okay, that is done. Now we will go to the last pair of faces. So we see this face, which is having the dimensions B and H. So I'll put that over my paper, and then I will take it. So this face, I will call it face number 5. And so we see that what we see is this B into H. This is a rectangle with the dimensions B and H. So this face I will call it 5. Now if, like last time, if you look directly opposite to this, you will see that this face is also having the dimensions B into H. So this face I will call it 6. And so I see that the 6th face is also having the dimension B into H. Now students, I wanted to look. Did we cover everything? 1, 2, 3, 4, 5 and 6. Okay, so everything is done. Fine. Now I want you to look carefully. So let us find the surface area now. Total surface area. The area of this rectangle is L into B. So area is equal to L into B. But we see that this same area is there for two faces, two rectangles. So I'll double it, multiplied by 2. Okay. Then here the area is L into H. And again two rectangles have that. So it is 2 into L into H. Here again, what do you see? The area is B into H. B into H. And again two rectangles had that. So 2 into B into H. So what is the total area? Total area is basically this plus this areas plus this areas plus these areas. So adding them all up, what do we get? Total surface area, or TSA, which is total surface area, is equal to 2 into L plus B. So 2 into L into B, I'll call it LB, plus 2 into LH. So this plus 2 into LH plus 2 into BH. So 2 into BH. Okay, fine. Now we just have to do a simple rearranging of things. So 2 is common, so I'll take 2 outside. 2 into, then what is coming inside? LB plus LH plus BH. And voila! Here is your formula for TSA, or total surface area. Now, why did I say total surface area? Is there any other type of surface area? Yes, there is. There is something called as lateral surface area. Lateral surface area is, let me just write it down and you will be able to, I think, understand it more carefully. Lateral surface area. So this was total surface area. This is lateral surface area, also acronymed as LSA. The short form is LSA. Now, you might hear many definitions of this, but let me just give you a way to understand. You have already come to see, I think so, that the word lateral means side. Lateral basically means side, because when we studied quadrilateral, we saw that quadrilateral means four side. Quadrilateral. So likewise, so from that we can understand lateral comes from the word which means side. So this is the surface area of only the sides. Okay, surface area of the sides. That is what LSA is. So if you have the cuboid, you can take the surface area of only the sides. Only the sides. Not the top. We don't take the surface area. We don't take the surface area of the top. And we don't take the surface area of the base. You see, only the surface area of the sides. And here, do you see that? So that is lateral surface area. Now it is not difficult at all, not at all difficult. Why? Because we can easily understand what it is. Now, you take any, so it depends on what side you consider as base and what side you consider as height. If there are 1, 2, 3, 4, 5, 6 sides. If you take any two sides off, any two opposite sides off, you will basically get the lateral surface area. For example, 1 and 2 are the opposite sides. If I keep 1 as the base, 2 will be the top. So lateral surface area is the surface area for the sides. So if I keep 1 as a base, 2 is the top. So leaving out 1 and 2, everything else becomes the lateral surface area. So these two, so adding this areas plus this areas will give me the lateral surface area. Now, if my base is for example, if my base is 4, then my top will become 3. So leaving the top and the base, take the areas of the sides. So what will be? It will be areas of 1 and 2 plus areas of 5 and 6. Do you see that? Similarly, if 5 was the base, 6 would be the top, and the area would be, lateral surface area would be 1 area in area 2 into L plus B plus this area. You see that? So that is what basically lateral surface area is. So the formula depends on what you consider as a base. Okay, so as a result, we can easily call the formula. I will consider 3 and 4 to be my base and top. So therefore, the formula will be 2 into. So if 3 and 4 is considered the base and top, the formula will be 2 into L into B plus 2 into B into H, which is 2 is common, so keeping 2 outside, into L B plus pH. 2 into LB plus pH. That is all. So that is all what lateral surface area is. Now students, this base and height can change. Base and height and length, all these 3 dimensions depends on what you call length, base and height. For example, if I call this base, I could call this height itself, and I could call this length. I could call this length and I could call this base. There would be no problem. These are all just the dimensions. What you need to remember is there are 3 dimensions, and excluding one pair of faces, excluding the base and the top, all area becomes the lateral surface area. Taking the area of everything is total surface area. As the name says, it is total surface area. And this formula, it never changes, it remains the same. But here, this formula can change depending on what is your base. For example, this time I consider 3 and 4 as base. If my base was 1 and 2, for example 1, if my base is 1 and 2, what is my LSA? My LSA will become, it will become 2 into LH, 2 into LH plus 2 into BH. What will it be? It will be 2 is common, 2 into LH plus BH. Do you see that? So it depends on what you take as a base and what you take as a top. Okay, which side you consider. So don't jump on by saying don't jump and use the formula when you see a question. Look at the question, look at the figure and see what are they talking about.